Hello students, welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are doing the last part of thermodynamics chapter. We'll be talking about spontaneity and Gibbs free energy. Okay, so you can join our WhatsApp channel, link is there in the description section. So you'll be getting access to all our PDF notes and class notes and mock test solutions, everything. So make sure that you join the WhatsApp channel. Okay, so now let's get started. So already we have discussed this, part 1 is over, part 2 is over, and in part 3 we are going to do spontaneity and Gibbs free energy and equilibrium. Okay, so this is going to be very important topic. Weightage of this chapter is like one question in KCET you can expect from the last previous year analysis. Okay, now today we are going to talk about spontaneity and Gibbs free energy and equilibrium. So in spontaneity we will be talking about enthalpy, okay, entropy and Gibbs free energy. And in Gibbs free energy and equilibrium we will be talking about the equation. Okay, so now coming to the first thing, that is spontaneity. What do you mean by a spontaneous process? Okay, this is a very important thing. So spontaneous reactions are those reactions, it is not that it, so when you hear the word spontaneous, okay, you think that it is a reaction which happens immediately or very fast, right? So that is not the correct definition of spontaneous. Spontaneous reactions are those reactions which occur by its own without any external agency. Okay, there is no external force required. This reaction or this process can take place by its own. Okay, so that is and it is an irreversible reaction which occurs without any external help and can be reversed by only external agencies. Okay, now here we'll be talking about some examples of spontaneous process. Okay, so for example, if you have taken a hot tea, okay, in a cup you have taken hot tea and you put that in cold water, okay, normal temperature water. After some time you will find that the water temperature has increased and the tea temperature has decreased. So if you see, always you can find that the heat flows from high temperature to low temperature, high temperature to low temperature. Now if you see a waterfall, okay, it always flows from high altitude to low altitude, or height from high region to low region, right? So we can say always waterfalls from high altitude to low altitude, right? So these are the process which happens by itself in nature. Okay, it is now the reason for this is the energy is conserved, right? But if the water flows from low height to high height, okay, then also energy will be conserved, but that doesn't take place, right? It always by nature, by process, it is always from high potential to low potential, right? So here comes the limitation of first law, that the first law, okay, limitation of first law is, it told you that energy is conserved, right? No doubt. But first law does not tell about the direction of reaction, does not tell about the direction of reaction. Okay. So now we understood that there are question may arise that why always water falls from high altitude to low altitude, why always heat flows from high temperature to low temperature. Okay, so these are the certain questions. The question arise here is why, like what is the criteria that decides the spontaneity of a reaction? Okay, what is the criteria that decides that whether a reaction can happen by its own or it needs some external help? Okay, what is that? What are the factors which affects the criteria of a spontaneity reaction? Okay, that we are going to discuss now. So the first thing that the scientists thought is about enthalpy. Now it is observed that generally, okay, generally those like majority of the reactions are exothermic. The majority of the exothermic reactions occur by themselves or are spontaneous. Okay, so a reason thought by the scientist here is, okay, the energy is released out, right? So the reactants from a higher energy come back to a lower energy, right? They are becoming from unstable to stable. When they are, because they are gaining the stability, they are losing energy. Okay, so enthalpy can be a factor to determine the spontaneity of a reaction. So here we found that most of the exothermic spontaneity can be due to the decrease in enthalpy. Why? Because the reactants are becoming more stable. Okay, the stability is gained when energy is lost. So endothermic process, but after that it was found that endothermic processes are also, there are certain, like, see, most exothermic reactions were found to be spontaneous. So we thought that, okay, in the exothermic process, because the energy is released, because the system is getting more stabilized, this can occur by itself. There was no doubt in this, but doubt came at that time when we found that certain endo reactions are also spontaneous. Okay, endothermic reactions are also spontaneous. Here you can have the example. So here we can see the example of reaction of N2 plus O2 to give you NO. Okay, so this reaction will give you spontaneous reaction, carbon plus sulfur reactions to give you CS2. These all are endothermic reactions, but they are also spontaneous reactions. Okay, so the thing that we came to know here, that enthalpy is not the only criteria. Only on the basis of enthalpy we cannot say that whether a reaction is going to be spontaneous or non-spontaneous. Okay, so there has to be some another criteria which can also tell you about the spontaneity of the reaction. So the second factor here is your entropy. Okay, now what is entropy? Entropy is a measure of randomness or disorderness. Okay, now see, suppose a gas molecule you have taken, okay, in a closed vessel, and you open the gas molecule, you open the lid, you will find that the gas molecules will scatter here and there, right? For example, let me tell you, you have taken a cylinder, okay, and then you have gas A and gas B, and you have a partition in between them. Now just if you remove the partition, okay, gas A and gas B will mix with each other, right? They will start flowing with each other. They will become more random. But if it is not possible again that these particles go back and sit separately, like gas A will come to one side and gas B will come to another side. So in nature, it is observed that always any process where randomness, disorderness is increasing, that process happens by itself. Now let me give you a very simple example. Suppose you are in classroom, right? Teacher is not there, right? Then there is a high probability that you all will be scattered, you all be moving here and there, you will be playing, you will be throwing chalks on each other or whatever, right? You are in a more disturbed, random and disorderness state, right? But when a teacher, when external agency comes in, forces you to sit in your place, then only you sit, right? So by nature, you can say it is observed every time that whenever a process is there which increases the entropy, which increases the randomness, which increases the disorderness, that process happens by itself. Okay, so entropy is that measurement of the disorderness or the randomness. Okay, so it is denoted by delta S. Okay, now it is increase in spontaneous reactions. Okay, if a reaction, whenever a spontaneous reaction is happening, there is no doubt that the entropy hasn't increased. Definitely entropy will increase. Okay, whenever a reaction, spontaneous reaction, whenever reaction has happened by its own. Okay, enthalpy, we have some exceptions that energy is taken and then the reaction has taken by its own. But in entropy, it is always observed that whenever a spontaneous reaction has taken place, whenever a reaction has taken by its own, the entropy has always increased. Okay, and entropy is a state function. We have already discussed what is state function, means it does not depend on the path followed. It always depends on the initial and the final state. Okay, now to explain this entropy in the mathematical form, delta S is equal to Q by T, where Q is the heat and T is the temperature. Now here one interesting thing we have to think here, that delta S is inversely proportional to temperature. Now see, suppose this is system A, okay, and this is system B. Okay, now system BA is at a temperature of 300 degrees Celsius, okay, and system B is at a temperature of 50 degrees Celsius. Now you gave Q amount of heat to A and Q amount of heat will B, right? When you provide heat, the molecules will get more energy, they will start vibrating, they will definitely become more random, more disorderness, entropy will increase. Now suppose you are giving Q amount of heat to A and Q amount of heat to B. Now what you will observe is the change in entropy. Okay, now see, what you will observe here is the change in entropy, the delta S will be more for the lower temperature, means the system which is at 50 degrees Celsius will show more randomness, more disorderness at lower temperature when you provide the same amount of heat. Okay, so that is there. Now delta S total is delta S system plus delta S surrounding, which is greater than 0. Okay, so always the total entropy will be greater than 0. Okay, now we have another thing here. For a reversible process, delta S increases, reaches to a maximum value, and then at equilibrium delta S is 0. Okay, so when for reversible process delta S value is 0, but for irreversible process delta S is greater than 0. We have discussed this one. It always increases in the spontaneous reaction, and we have discussed that the spontaneous reactions are irreversible, so that is why delta S is always greater than 0 for irreversible reactions. Okay, and next if you talk about delta U, it is always equal to 0 whether it is reversible or it is irreversible. It doesn't matter here. Okay, but delta S for reversible it is 0, for irreversible it is greater than 0. Okay, fine. Next we will talk about Gibbs free energy. Now you see there are two criteria which defines the spontaneity of a reaction, enthalpy and entropy, right? But none of the two criteria is 100% accurate. Okay, enthalpy we have some exceptions, entropy alone cannot tell you whether a reaction will be spontaneous or not. Okay, so there is something, there is a factor, there is something which combines these two factors. Okay, and that is your Gibbs free energy. Okay, it combines both enthalpy and entropy and give you this equation delta G is equal to delta H minus T delta S. Okay, and here if delta G value comes out to be negative, then the reaction is spontaneous. Okay, if delta G is negative, then the reaction is spontaneous. Clear? Okay, now coming to the next one, that is Gibbs free energy and equilibrium. Okay, so we have a formula here for Gibbs free energy is equal to minus 2.303 RT log K. Okay, now here what are the things that you should know? That R is a gas constant, universal gas constant. Okay, and T is temperature. Okay, and K is equilibrium constant. K is equilibrium constant. Okay, so with this calculation you can calculate the equilibrium constant value. Okay, fine. Now coming to do some questions. Okay, so combustion of glucose takes place according to the equation. This is the equation given, delta H value is given. Energy required for the production of 1.6 gram of glucose is. Okay, now see, that means when this 1 mole, okay, 1 mole of glucose means I can say 180 gram of glucose. Okay, 180 gram of glucose burns, then how much energy is produced? 72 kilocalorie. Okay, now for 1 gram of this one, for 1 gram what will be the value? You have 72 by 180. Then the question is asking for 1.6 gram, for 1.6 gram of glucose. Okay, so that is 72 by 180 into 1.6. So if you solve this, okay, you will be getting around 0.64. Okay, the correct answer for this question will be option number 2. Okay, next we'll do today's question. Spontaneous reactions that occur are mostly, okay, we have seen that they are exothermic in nature, so option number B, mostly exothermic, but yes, certain endothermic reactions are also spontaneous. One example is your melting of ice. If you just keep an ice by itself, it will melt and it is an endothermic process. Okay, but generally they are exothermic. Next question number 2, reaction is spontaneous if Gibbs free energy is less than 0, right? It should be negative. Gibbs free energy should be less than 0 for a reaction to be spontaneous. Delta S, entropy, should be greater than 0 for a reaction to be spontaneous. Enthalpy can be both positive or negative for a reaction to be spontaneous. Okay, so what I am saying, delta G should be less than 0, delta S should be greater than 0, and delta H can be less or more than 0. Okay, it can be both positive and negative. Okay, next question number 3. If the enthalpy is positive and entropy is negative, what would you understand about the Gibbs free energy? Okay, enthalpy is positive and entropy is negative. You have delta G is equal to delta H minus T delta S. Okay, enthalpy is negative. Okay, enthalpy is positive, and you have entropy is negative, T into minus delta S is negative. So if I multiply this, I'll get this one, okay, plus T delta S. Okay, now you see both the terms are positive, and you add this one, then delta G will also come out to be positive, and delta G positive means it is a non-spontaneous reaction, because just now we told you that for spontaneous reaction delta G has to be negative, right? So it is positive. So Gibbs free energy will be positive. Option number A is the correct answer here. Okay, now question for solving. Calculate the Gibbs free energy for the reaction of conversion of ATP into ADP. So you have this reaction, ATP is converted to ADP. Okay, at 293 Kelvin, temperature is 293 Kelvin. Okay, and the change in enthalpy is 19.07 calorie. So delta H is 19.07 kilocalorie. Okay, and the change in entropy is 90 kilocalorie or 90 calorie. Okay, Kelvin inverse. Okay, so now you need to calculate what? Gibbs free energy. So delta G is equal to delta H minus T delta S. So delta H value is how much? 19.07 kilocalorie. So I will make it 19070 calorie. Okay, next I have T is 293 Kelvin. Okay, and delta S is 1990 Kelvin. Okay, now if you solve this, okay, if you solve this, you will be getting around minus 7.3 kilocalorie. Okay, the correct answer for this question will be option number D. Okay, next question number 5 here. Calculate the Gibbs free energy for the conversion of oxygen to ozone. Oxygen to ozone. Okay, at room temperature, if Kp value is 2.47 into 10 to the power of minus 29, temperature is room temperature means 25 degrees Celsius means 298 Kelvin. You need to find this one. So we have this one, delta G is equal to minus 2.303 RT log K. Okay, now if I want to calculate this log K, it will be delta G equal to 2.303 RT. Okay, now what is the value of delta G here? What you need to calculate? Okay, you need to calculate, one second. Okay, sorry, we need to calculate delta G only. This step is not required. We can directly substitute the values and do the calculation, right? So we will have minus 2.303, R value is 8.314. okay, then temperature is 298 into log K. K value is 2.47 into 10 to the power of minus 29. Okay, now if you solve this, okay, you will be getting around 163 kilojoule per mole. Okay, the correct answer for this question will be option number A. Okay, fine. One more question here. Okay, so this is the question, homework question. Okay, homework question. You need to do this question and I will be telling you the answer for this in the next class. So in a reaction, the change in entropy is given, change in Gibbs free energy is given, calculate the change in heat at the temperature of 20 degrees centigrade. Okay, you need to calculate this. Try this question and let me know and put your answer in the comment section. Okay, so yes students, that was the end of the thermodynamics chapter. In the next class we will be solving most important previous year questions of both KCET and Comet K. So please subscribe the channel so that you do not miss out on any important videos. So thank you for watching, and please subscribe the channel once again, I'll say, because this will definitely help you in your KCET preparation. Okay, and see you soon in the next class.